Hi all, and our second video in our Python plus DSA introduction series. I already mentioned I will cover these kind of topic in the coming series. I got a lot of comments in personal message. Thank you so much. So we can start it. And today's video I will discuss about the time complexity. We already know the first thing is time complexity and space complexity. Then we move to the next part. So the time and space complexity is important. So today's video I will discuss about the time complexity. So what I meant by the time complexity? I think everyone know, but I'm just refreshing. The time complexity means the amount of time is taken by the program. So that is the total time complexity. So for example, you don't need to think about a small program like print your name, print the n number of leaves, don't like that. You are working in a project contain 100 team members. So you can imagine that you have a big repository, and the thing is like that you have a lot of check-in every day. The developer, each and every developer checking their code into that particular repository, and the end of the day they will get a big repository, right? Not big, that means that much of check-in will happen there. So that situation, what we can do, definitely each and every developer need to do optimized solution. Otherwise the time complexity of the code will be high. Definitely you want to know, right? The client also looking like that. They need optimized solution. They want efficient and faster solution in right now. So that is the main reason we are just aware about the time complexity. So if we are aware about the time complexity, if we write the single line of code, we know this will be take more time. Is there any alternative or any optimization technique available? We just Google it and find it and implement it. So that is the reason I'm just specifying the time complexity is very important. So we can get started. And the time complexity means there is we are mainly focused on the three kind of things: the omega, theta, and the big O notation. So these are the cases you can already see here. The time complexity is there, best cases is there. We can always taking the best cases. Okay, we definitely think about the best cases always. So the best cases, the average cases, and the worst cases. So definitely we write a program, we think about each and every situation. If we get the better solution, then we implement it. By practice, we can speed up this skill. So that is the reason we definitely do some of the programming in the data structures. So this is the first thing want to know. So as a developer, we want to write a code like a worst case, that means the omega. And I will tell you some kind of situation, just aware about. This is the overall idea. I already prepared one deep session in the YouTube videos. I think I will add that video in the comment section. You can check it and you can watch. Actually, I write all the points in my book and I explain the deeply. So this course I will cover all the idea, what are the things in the time complexity. So I will tell you. Okay, I will. So for example, like I want to find the number of 100 numbers. So normally what the programmers think, they are normally doing for statement, right? For I in n. Okay. For example, this is my array. I will write here 1, 2, etc., etc., 100. I want the sum of all the items. Okay. So normally programmers, what they do, they implemented one for loop for I, each I plus sum equal to 1, then again next iteration plus 2, and etc., up to 100. So this is the normal one, normal developer do. But if the developer who know the data structure, what he will write? He will write these kind of code. So this is the easiest implementation, n into n plus 1. So this is the shortest formula to find the continuous n numbers. Okay. So this is the one using. Why the best developer use this one? I will tell you. You already know the program definitely need to take time for executing each and every line. For example, we will write 1, 1. This is the unit of time to take. And for this one, you can see n iteration. That means this loop will be n times, right? N times it will be iterate. This one. This will be n times iterate. Okay. So this is n and this will also 1. So the total time means the total time of this one will take 1 plus 1 plus 1 n plus 3. So this is the total unit of time will take. Okay. So that means, for example, if the n equal to 100, this will be 100 plus 3. If it is 1 core, what will happen? The amount 1 core plus 3. So that will be a huge number, right? That much of unit time will take to execute this whole program. This is really hard, right? It is the pain point. Yeah. So this is the pain point we already discussed, because if it is 1 core, the programming size is 1 core, that we want to compute, because you already know, right? Data is flowing through right now. So we cannot imagine what is the number. So 1 core is a less number, okay? So that you remember it. So here you can see this is the pain point. So that time we definitely want to implement another solution. But if this solution will definitely know the only person who think about the time complexity. So that is the importance of time complexity in the program. So for example, here you can see that this take 1 unit of time, and this one also take 1 unit of time, and this one also take 1 unit. Total 3 unit of time. 1 plus 1 plus, there is no follow. This is a simple formula. If it is 1 core, if it is 10 million or anything, okay, this will take only 1 unit of time. So that is the optimization trick. That means we can save this much of data, this much of time by using this single implementation, single line of code. So that is the reason we definitely want to know these kind of items. So I hope you are understood why we need to do the data complexity, time complexity. Okay, and yeah, so coming back to here, you can see that normally we are preferring constant time. This is the order. Normally each and I will discuss which program need this kind of data. C means constant time. This is C right? So graph like this one, I will tell you the graph. For example, this graph means time n. Number of n is given, it is like this. Okay. But here we can see that time n. This is like constant. So this is the difference. So this is the powerful one, right? So that's why we are choosing this solution. So I hope you understand everything from here. And this is you just notice this is the order. Normally we want constant time of data. If the solution gives constant time, that is better solution. If it is less than this, we can flowing through like this. Okay. So this is why the time complexity. This is all about the time complexity. So I will add that link in the description box. You can check it, and you will get better idea how I going through all the things. I referred lot of notes, and that's why I implemented one notebook inside this YouTube video. So you can check it out. And the next video we will discuss about the space complexity. Yeah.